Hello, everyone. So today we are going to go through 7.3, just a one-day section. It's pretty quick. It's pretty easy. It's all about what we call special products of binomials, which is something that sounds a lot more complicated than it actually is. All right, we've got a quick vocab. I think we've already done this, but remember binomial, we've got two terms. So I know we did a little bit of multiplying with trinomials yesterday, but all of these special products that we're going to do today, it's just when we multiply two binomials together, and it's only certain ones. This isn't going to be every FOIL, every multiplication problem that you see. There's just special times when we can have these, they're kind of little shortcuts that we can use with certain types of binomials. All right. So let's look over here. We've got two types. We've got the square of a binomial and sum and difference. And again, this is one of those things, you look at it at first and it looks really confusing, and then you realize that it's super easy. Okay. So first off, let's think about what this really means when we have this a plus b squared. This formatting throws people off a lot of the times because we're not used to seeing it like this. Okay, a plus b squared. Okay, so the first kind of trick to that is we have to think of that as, well, that just means take that a plus b and it's being multiplied together. So it means I've got a plus b times a plus b. And the thing to keep in mind with all of these, if these tricks and stuff, they're hard to remember or they don't really make sense, that's fine. You can just FOIL them out. Okay? You can FOIL them out or use the table method. Anything that we've already done works with these. These are just kind of extra special little shortcuts so that when you do recognize these little patterns, you can realize, oh, this is a special case, move through it super quickly. It's also going to help when we do factoring, when we go backwards, if you can recognize some of these special ones. Right? So that first one, you've got a little binomial squared. I've got x plus 5 squared. All right, that's the same thing as x plus 5 times x plus 5. All right, so I could FOIL it out. I could say, okay, first I've got x squared outer. I've got, okay, x plus 5, x times 5, I've got 5x. 5 times x is also 5x. And I've got 5 times 5. I get 25. So that's going to simplify. I'm going to combine my like terms, and I'm going to get x squared. 5 plus 5, I get plus 10x plus 25. But the quicker way to do this problem is to use the pattern. All right? When we have this little a plus b or whatever the different binomials are, okay, something all squared, it's always going to be the first term squared. Okay, we see that. The first term is x, we get x squared. Then the middle term is 2 times a times b. Okay, think about what that means. 2 times a, 2 times the first term, so 2 times x, times the second term, 2 times x times 5. Well, 2 times 5 is 10, times x is 10x. Okay, 2ab, okay, that's 2 times the first term times the second term. Then the last one, we get b squared. Okay, that's that second term squared, so my second term is 5. I get 25. Right? Notice that when you have a plus sign here in the middle, I start underlining, plus sign, everything is a plus sign. Okay? So when it's positive, everything is positive. Right? So again, see, this is a shortcut. If you can use this easily, awesome. It saves you some time. If this whole time I've been talking, you're going, what on earth is she talking about? That's also fine. Just FOIL it out, use the table, whatever you've been doing. This is supposed to help you. If it doesn't help you, throw it in the trash, use the normal method, okay? Next one, almost the same exact idea, except now we're subtracting. Okay, I've got this minus sign here. So let's see how that changes this a little bit. Okay, exact same idea. 2x minus 3 squared means 2x minus 3 times 2x minus 3. That's what that means when you see that exponent there on the outside. So again, I could FOIL it out. Okay, first I've got 4x squared outer 2x times negative 3, so negative 6x. Inner negative 3 times 2x, that's negative 6x. And then last, negative 3 times negative 3, get positive 9. Okay, get 4x squared minus 12x plus 9. But again, like the first time, there's an easier way to do this problem. I can leave this as 2x minus 3 squared and look at this pattern right here, this a squared minus 2ab plus b squared. All that's saying is I can go from here and then just directly say, okay, well, I know that first term is going to be squared. Okay, you square the whole thing, even the coefficient. So 2 squared is 4, x squared is x squared. Then the middle term. When you've got a negative, it's a negative term right here in the middle too. Okay, so negative 2ab, negative 2 times your first term times your second term. Okay, so you've got 2 times 2x, that's 4x, times 3, that's 12, and you know it's a negative sign right here, minus 12x. And then b squared, all right? 3 times 3, 3 squared is 9. You're always adding that last term, okay? Even if it's two negative numbers, when you multiply them together, obviously you're going to have a positive, okay? Again, if this method is quicker and easier for you, awesome. It's going to save you a little bit of time. If you are very confused on how I did that, ignore it. Foiling worked just fine, okay? This is all to help you. None of this this is not ever just going to be to trick you, okay? Alrighty, let's go on to the very last one, right? This one's a very specific one. So notice before, everything is just the same binomial repeated. I had x plus 5 times x plus 5, the exact same. Over here, 2x minus 3 and 2x minus 3, same sign and everything. With this one, the terms are exactly the same. The a and b are exactly the same, but one is a positive, one is a negative. Okay? The example it gives us positive first and then negative, but remember with multiplication, the order doesn't matter. It could also be a minus b, a plus b. Okay? Order doesn't matter. These are the exact same thing. Right? So again, the two terms are exactly the same. You just have one positive and one negative. All right. This one is a little bit easier, and I think more people remember this rule because it's kind of a little bit simpler, I think. Okay, let's look at this example right here. You've got x plus 3, x minus 3. Okay, we could do the math here like we've done before. I'm going to FOIL it quick. Okay, we've got our first terms. That's x squared, outer, negative 3x, inner, plus 3x, and last, negative 9. Okay, be careful with our signs. Okay, negative 3 over here in the second term, so just make sure, okay, negative 3x, negative 9. Just be careful with that. That's one of the easier ways to make a mistake. All right, then I'm going to combine my like terms, and let's see. Over here, we've got a negative 3x and a positive 3x. Okay, if I really wanted to, I guess I could write 0x, but that's not the most simplified it could be. If you have a 0x term, Sometimes people try and simplify that down to just x, but it's really just nothing, right? 0x is just nothing. I'm going to skip that term completely, right? I'm just going to go x squared minus 9. If it really helps, you can write it out x squared plus 0x minus 9. But then I would simple it out to just x squared minus 9. Simplify it out. I don't know what I said. Just that x squared minus 9. All right? So you could do all the foiling and everything, or you can just remember the trick. You can say, okay, well, when I have the exact same terms, okay, A and B and the A and B, just with different signs, the answer is going to be A squared minus B squared, right? You get x squared minus 9, okay? This, when you square x, you get x squared. When you square 3, you get 9, okay? The thing to remember here is you're always subtracting. It's always x squared minus 9 or 4x squared minus 16 or whatever, okay? If you ever end up with x squared plus another number, you made a mistake. Okay, the only way that you can get something like this is if you use imaginary numbers. That's not a joke. I mean, you actually can do it if you use imaginary numbers, but you don't have to worry about those till algebra 2. All right? So make sure you're always subtracting on these. That's probably the easiest mistake to make on this. All right? And again, if that's too confusing or you know you're not going to remember it, we ended up with the exact same answer when we FOILed this out. Okay? So go ahead. You've got a couple questions on your 7.3 assignment. Go ahead and get started on those, and we'll see you guys later. Alrighty. I know we already did a video explaining this, but I feel like I did a lot of explaining and not enough just straight examples here. So I'm just going to work through a couple problems just in case it helps to see this whole process worked out a little bit more. Right? So I'm going to write up here the different rules for us to kind of remember. Right? I could have a plus b squared. I know that's going to give me a squared plus 2ab plus b squared. Right? Or I get a minus b all squared, and it's exactly the same, except I know I'm subtracting that 2ab. Okay, still adding that b squared. Or I could get that a plus b, a minus b, and I know that's just going to be a squared minus b squared. Right? So let's look at a couple. Let's do a couple with a little bit harder math than I did earlier, so we get some better practice. Okay, over here, this negative 2x plus 1. Right? Negative 2x plus 1. I know this is an a plus b squared problem. Right, so I know it's going to be a squared plus 2ab plus b squared. Right? So I've got all right, so let's think about what our a and b are. I've got my a right here, that negative 2x. So, okay, negative 2x squared plus 2 times a, which is negative 2x, times b, which is 1. And I'm always going to add that b squared, so 1 squared. Okay, I can simplify all this. So negative 2x all squared is going to be 4. Okay, negative 2 times negative 2 is 4. And then x squared. Okay, then 2 times negative 2x here, I'm going to get negative 4x. And then I know 1 squared is 1. All right, let's do right here next to it. I've got a minus b squared problem, so let's do that quick. All right, so a minus b squared. I've got a squared minus 2ab plus b squared. All right, so a squared, I know that's going to be negative 4p squared minus 2 times A, okay, for P. And then when it says B, I know this is a little confusing. You feel like you should be putting -3, but it just considers the B to be the kind of the absolute value of this because it's already saying, okay, it's minus B. So the only thing you're considering to be B is just the 3. So you're going to say 3 right here, and then plus B squared. So B squared is going to be 9. I'm adding it. Oh, I guess I should write it as 3 squared if I'm not simplifying on this line yet. All right, then final answer, okay, -4P squared, so -4 squared is positive 16. Then I've got P squared. Okay, I've got -2 times -4, so I've got positive 8 times 3, I have positive 24P. And then 3 squared, okay, I've got positive 9. Right? And that's my final answer here. I should have boxed this one up too. Alrighty. Let's go into a plus minus one here. Let's do 12. These are nice and easy usually, just one step. Okay, so t minus 11. So rather than writing out that, let's write out the rule. I've got a plus b and then a minus b. I know that's always going to come out to a squared minus b squared. Okay, so here my a is t, so that's going to be t squared minus, okay, my b is 11, so 11 squared is 121. All right, this one's pretty easy for most people. I would definitely use the little shortcut here on the adding and subtracting ones. Again, I know for some people this special rule is a little confusing. If it's confusing, again, just write it out as the 2 different binomials and FOIL it out. Right? I'll see you guys later.